So for homework over the weekend, if I just go back and look at one of the problems real quick. You guys did problem 8 on the homework last night that says, hey, I have triangle ABC, part A do this, part B do this, and part C do this. I'm just going to put it all in one problem today. Instead of going parts A, B, and C, I'm going to put it in one problem. And what you guys have been doing by doing these different parts A, B, and C is what's called a composition. Okay, composition. There is a symbol for composition that you know what's going on, and it almost looks like a degree symbol. Okay, so that's the symbol for composition. It looks like a little degree symbol. And here's how a composition is written out for a classic example. So I have a translation of 2, -6. Then you see your composition symbol with a reflection through the y-axis. So basically, right, it's a part A-B question I'll put into one. You know, you're going to translate and you're going to reflect. Here's the part you got to focus in on is, which one do you do first? And this is probably going to be the most awkward, uncomfortable position for a lot of you guys when you do compositions, because compositions are completed right to left. Okay? Completed right to left. All right, so compositions, I'm going to do them right to left. So if I go ahead.
Why are they completed right to left?
This is, I don't know if this is 100% true, but here's my guess, is because when you write them, what you're going to complete the composition on is written right here. So you're going to do this composition on ABC, and I'm assuming because they're right together, that I'm going to do that first and then work to the left. Okay, that's my bet. I don't know if that's 100% correct, but that's my thinking. All right, so if I was asking you to do this composition on triangle ABC, we'd first reflect, take those points, and translate. All good? Questions? All right, so we're going to actually, instead of using coordinates, we're going to use pictures here in the first one. You guys see I have 2 parallel lines, L and M, and I got the capital letter B. Everyone see the composition I'd like you to perform right now on B. You guys see a reflection through line M composed with a reflection through line L. And we just said I need to complete these right to left. So what are you going to do first with that B? What's that composition telling you to do first with capital B? Quincy, what's it showing you? What's it asking you to do?
Rotate.
Whoa, my heart. Reflect through?
Line L.
L. Complete it right to left. So everyone go ahead. Do your best impersonation of capital B reflected over line L. Kyla, go ahead.
When you do the reflection over line L, would you call that a B prime, or would you just not call it anything?
It's not a coordinate, so I wouldn't call it anything. Okay? I only want to do that when I'm talking about coordinates. I'm just doing it for a figure here. And then keep going to the left. Now take that B and reflect it over M. So everyone go ahead, do your best capital B over line M now. Distance does not change. I can do better than that. And that's where I end up. So here's my first challenge question to you today, kids. Instead of doing 2 reflections, what transformation could I have done to my original B to get to my ending B? That's my first challenge to you. Instead of doing 2 reflections, what could I have just done right from the get-go to get from the beginning B to my ending B? I could have done, Omni?
A 180 rotation,
A
right?
180 rotation. Okay, I got it. Around where though? See, that's, you would have to tell me, like usually I rotate around the origin. I would need to know around where. I see where I'm getting the 180 from. So simplify it for me. Don't get so hardcore, rotate 180. I think you're overthinking it. I could have just done what to go from here to here? Anybody?
Translate it.
At home, go ahead. Okay, or not.
Translation.
I could have just done a translation. All right? And that is the case every single time. What type of lines were L and M? If I ever ask you to reflect over two parallel lines, it's the exact same thing as doing a translation. Anytime hey, can you reflect over these two parallel lines? Oh, I'm going to do a translation. Yep.
If you just have 1 point, couldn't everything be achieved in the translation?
Say that again.
If you just have one, like if it's just 1 point that you're moving, couldn't you just translate that?
No. The lines have to be, watch, we're going to do one right now where the lines aren't parallel, and you're going to see it's not a translation again. Okay? I see what you're saying, but not if the lines aren't parallel, it won't be a translation. Here's why. Everyone take a look. Now, same composition. Everyone go ahead, take C and reflect it through L. Do your best C impression there. Reflect it through L. Flip it over L. Let me know what it looks like. Okay, there's my C. Then take that and reflect it over M. Uh-oh. Usually kids have the toughest with this one. It's fine. Pretend you're folding your paper along line M, everyone. Pretend you're folding your paper along line M. And then what's that C look like on the other side? Okay, now, what single transformation could I have done to my original C to get to my ending C now? Not a translation, right? Because there's no way I could move up, down, left, and right to match those up. What could I have done instead? Turn it, a rotation, yes. So now, anytime you reflect over two intersecting lines, it's the same as doing a rotation.
Will we ever have to specify how many degrees?
Now, just know that, hey, when I reflect over two intersecting lines, that's equivalent to a single rotation. All right. Anything you'd like to ask before I get to the final special composition? Go ahead, Avi.
So what if we have two lines that aren't parallel, but like on the page they don't intersect?
I have to. I'm going to have to extend them then. All right? I only have two, unless they're skew lines, but this is not three-dimensional space here. Okay? So they either have to intersect or they have to be parallel. All right, you ready to get a little dancing in? With the last special type of composition. Ready for a little dancing at home? You guys got your music. You may want to jack it up right now. Called a glide reflection. A glide reflection. What's it sound like? Glide, meaning I'm probably going to do what? And it's already in the notes, but glide. Like I'm not going to do it again.
Slide.
Slide. Big boy, big girl word for slide. Translation, yes, it's a translation and a reflection. Okay, it's a combination. Order doesn't matter. Order doesn't matter. You can translate first or you can reflect first. Order doesn't matter. Here's what makes it a glide reflection, because it can't be any translation and any reflection. Here is what matters and what makes it a glide reflection. Let me just, and you guys don't have to copy this down. I'm just using this for visual here. Let's say I start with triangle ABC and I want to reflect it over the y-axis. Okay? Woo! Flipped it. Here's C prime. Here's A prime. Here's B prime. Now I have to translate. But hey, I cannot slide it anywhere I want. If it's a glide reflection, you need to slide, ready? Parallel to the line you reflected over. What line did I just reflect over? The y-axis. So my slide, my translation, has to be parallel to the y-axis. Okay? It can't go left, right. It's got to go up or down. So here, and again, sorry for not being drawn to scale. Here's an example of a glide reflection from A, B, C to A double prime, B double prime, C double prime. Reflect and slide parallel to the line you are reflecting over. Oh, you guys are so lucky this year because we'd be taking a trip out to the hallway and I'd lay down a strip of tape and everyone would be doing the glide reflection out there. All right, lucky this year. Questions? Glide reflection, translation and a reflection, but the slide has to be parallel to the line you reflect over. So those are our three special types of compositions. Now let's actually try one on the graph. So go ahead, on the next problem, draw up triangle text. Draw up triangle text for me. Everyone see the composition I'm asking you to perform. They're completed right to left. Complete the compositions right to left. So out of the reflection and the translation, which one are you going to perform first on text? Out of those two, which one do I perform first? Come on, there we go. Ones, there you go, Anthony. Which one are you going to perform first?
The translation.
There you go, translation. So everyone, what's the 0 telling me to do to my x?
Keep it.
Nothing, right? Meaning you are not going to move right or left. The only thing I should be doing, what's the -5 telling me? What's the -5 telling me?
Down 5.
Going down 5. So nobody's moving right or left because there's a 0 there, but we all are moving down 5. So let's do it. And these will be our prime coordinates. T prime, E prime, X prime. Then keep going to the left. Keep going. Now I'm going to take my prime coordinates and reflect them through the y-axis. And those will be my double prime coordinates. I just keep going to the left. And you always, and no one asked this yet, but you always work on the previous set of coordinates.
So does that mean that a transformation in a glide composition will only have a number in one of the transformations? Like you won't move it down 2 and to the right?
Correct, because that would not be parallel to the y or the x. And then I don't know if anybody just heard Sophia, but she's basically saying, and she is correct, we just performed a glide reflection. What line did I ask you to reflect over? Y-axis, and where did you slide? Parallel to the y-axis, down 5. Okay? So that is an example of a glide reflection. Any issues there performing your own? Whew. All right, I'm going to the bell today. New vocabulary, orientation. Orientation. Direction of vertices on a figure. And I will go into deeper explanation here in a second. Direction of vertices. Here's what I mean. Go back to triangle TEX for me. As you go from vertex T to E to X back to T, are you going clockwise or counterclockwise? From T to E to X back to T. That is what type of direction? Clockwise. Everyone in agreement? Clockwise. So I would say triangle text has a clockwise orientation. Clockwise. Now go to the prime one. T prime, E prime, X prime. What type of orientation do I have there? Clockwise or counterclockwise as you go from T to E to X back to T? What type of orientation? I should just keep calling up people. What do you got for me, Audrey? What type of orientation? T to E to X back to T.
I don't know where left from rights. Well, clockwise.
Clockwise, good. All right, everyone good? Now go to the last triangle, the double prime. T to E to X back to T. What type of orientation now? What do you got, Quincy?
Counterclockwise.
That's counterclockwise, all right? Now, I just did T to E to X because that was the order it was given to me. You could start, you could go to X to E to T back to X, but whatever order you go in, you need to go in the same order for the rest of the triangles, all right, to make sure you tell me what orientation they have. All right, so now big challenge for these honors kids. You guys remember what rigid motions were at the beginning of the unit? Anything that doesn't change.
The angles.
Angle measure or
The length of segments.
side length, yes, segment length. So give me an example of a rigid motion that we've already talked about this unit.
Translation.
Translation, give me another one.
Rotation.
Rotation, and there's the only other one we did.
Reflection.
Reflection. What's not considered a rigid motion? Which one?
Dilation.
Dilations. So now here's what I want you to think about. Out of those rigid motions, reflections, rotations, translations, which one would have same orientation after I perform them? So if it started in a clockwise direction, I end in a clockwise direction. Translations, rotations, reflections. Which one keeps the orientation the same? And think about the triangles text we just did here. Which ones would keep them the same? Orientation the same. Rotation, reflection, translation. What do you think? Which one's going to keep them the same? 1-8. Owen, what are your thoughts out of all those we just discussed? Which one will keep the orientation the same?
Translation.
There's one, translation. If you slide a figure, you're not changing the order of the vertices. Translations. Got it. Think you got another one on me?
A 180 rotation, right? Because it's
Well, any rotation, not just 180. Right? Here you go. Here's a triangle. ABC. Ready? Well, first of all, if I go ABC, that's clockwise, right? ABC. So let me turn it. Still clockwise, right? So it doesn't matter what you rotate it. Rotations will have same orientation. And there's one more we have not yet discussed this unit. We will later on after the quiz, and that is a point reflection. All we have done is reflected over a line, but you can also reflect through a point, and that will not change a figure's orientation. All right, which one will then? What will change a figure's orientation? Sophia? Reflection. I'm just going to get a little bit more specific because we can do different kinds. Line reflection. If you reflect over a line, you will change the order of the vertices. And there's one more actually that we just talked about today. That involves a line reflection. What did we just talk about today that involves reflecting over a line as well?
composition.
Line. Reflections.
Glide reflection, right? Glide reflection. Good job, Sean. Okay, glide reflection. Because you are reflecting over a line, so that will change the orientation. Anything you guys want to ask about orientation? Because from here on out, the rest of the class, a lot of the work is going to be on your own. Anything about orientation? All right, so I'm going to let you guys go on this next set of 4 questions. I go from one quadrilateral to the next. What did I do? Did I reflect? Did I rotate, translate, or did a glide reflection was performed? And remember, glide reflection is flip and slide along the line you reflected over. So I'm going to give you guys a couple minutes. Take a look. How did I get from one quadrilateral to the next? It's got to be one of those 4 choices. So go ahead. All right, what do we think here? How did I get from one to the next? Let's start with ABCD to GHCD. Let's start right there, top of the page there. Vinny, how'd you get from one to the other, number 1?
Reflection.
Yep, that is definitely a reflection without a doubt. If anybody needs me to go over any, let me know. That's a reflection. 2, how did I get to those 2? 19, here you go, Sean. How did I get to one or the other?
Rotation.
That is a rotation, correct. Some people may say that's a glide reflection, but after you flip it over the horizontal line and try to slide it, they wouldn't match up to each other. All right, a lot of people tell me glide reflection, but after you flip it and try to slide it, the vertices wouldn't correspond with each other. 3, doing a good job, guys. What's 3 look like now? 13, here we go, Sophia. That is indeed, good work, glide reflection. That is a glide reflection. And finally, number 4, how did I get one on top of the other? Here we go, Audrey, what do you got?
Translation.
Yep, just slide that figure right on top. Perfect. Guys, all good? Because now really I'm going to go hands off now. Now here's where I need you to get to do pretty well the second half of the unit. You tell me what happened. Okay? As you guys can see, I have pentagon A, B, C, D, E. I performed a sequence, meaning 2 or more. I performed a sequence of transformations, 2 or more, and ended up with that double prime pentagon. What did I do? And you guys can see the first 4 choices. Now, how should you attack this problem? Here's what I'm thinking. Is you just pick a coordinate to start with. Let's say you start with coordinate B, which is, let's see, 2, 1, 2, 3, 4, 5. Coordinate B, which is 2, 5. And I end up at B double prime, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5, -5. Which one of these 4 brings me from 2, 5 to -5, -5? And I probably wouldn't be satisfied with just finding one coordinate. I would just double check to make sure it works with the second coordinate as well. All right, so you're going to go through your 4 choices right now and see which one of those sequence of rigid motions brings one onto the double prime. This really makes you work here. And then just stop at number 1. Don't go on to number 2 because I'm going to go to a different question.
So can you just like go through here and like, I don't know, we'll memorize for a rotation, couldn't you just, you know, graph it and then graph the 1 point at least?
Yeah. Yeah. So where does 2, 5 go after a rotation of 90? And then doing the second one, does that bring you on to -5, -5, B double prime? This is by far the toughest part of the unit. Is figuring out how do I go from one figure to the next. And this is just multiple choice now. So at least you have things to test. And just keep going. I don't want to reveal it till everyone's had a chance here. We should be at choice number 2 for this one. Or rotation of 90 counterclockwise. Make sure you remember what counterclockwise is. To your left. To your left. And then moving everything down 7. Now, to make this even tougher, remove the multiple choices and go to question 3. Now you're on your own. How do I get A, B, C, D on the A double prime, B double prime, C double prime? And again, I can't, hey, before you move on and try this, directions say, describe a sequence of transformations. That means more than one. If you just write reflect over this, not good enough. You need to at least give me 2 or more. You can have more than 2, that's fine. You can have 3, 4, whatever gets the job done. But it's got to be more than one transformation that puts those 2 on top of each other. It's going to get tough now. So should I rotate first? Should I translate? Reflect first? Look at where A and A prime are. Look where B and B prime are. You're going to have to do something other than just flipping them. You can write it in words what you're going to do, or you can write it as a composition what you're going to do. Whatever you do first goes to the right. Whatever you do second goes to the left. So you can do this in your own words, or you can do it as a composition. Either one is perfectly acceptable. You can't give up, though. That's not an option, is giving up.
If you're going to write it as a sequence of transformations and then like in shorthand, would you still put a comma at the end?
What do you mean? Like, are you saying,
Like for reflection, I would put like R and then I would put y-axis.
correct, yep, just like it would be written out, yep. If there is a positive to these problems, I know that it makes you work, and it's tough, it makes you work. You gotta think hard about this. One positive is there's just not one right answer. All right, but please, hey, before you're satisfied with your answer, make sure it works on multiple coordinates. Just because it may work on A to A double prime, make sure it works on B to B double prime. I'll reveal mine here in a couple minutes, what I came up with. But it doesn't have to be what you came up with. And I try the same thing as I showed you guys last problem. 1, 2, 3. Point A is -3, +2. A double prime is 1, 2, 3. 1, 2, 3, 4. 3, -4. So I try to match those coordinates somehow up. All right, here's what I had anyway. Let me just show you how to write it in words, and then I'll write it as a composition. I have a rotation of 180 degrees, followed by a translation down 2. There was no right or left for me. I just went down 2. I didn't have to go right or left. If I wrote it as a composition, ready? I rotate my composition symbol. I rotated 180 first. So that'll go to the right, followed by a translation, 0, -2. Or if you want to put that in vector notation or function notation, you could as well. And that's just my version. Are there other versions? Darn right there are. There are other versions. But that's where we're going towards now. All right. I know this homework's not due until Thursday, but that's where we're going towards now is you guys having the ability to tell me what you do in 2 or more transformations to map one figure on top of the other. That is where we're going.
Are you going to write in composition form if it's more than one? Would you just put another degree symbol?
So you did 3, right? So whatever you did after the translation, yep. Tell me. I just keep working to the left.
Oh, the first
So I'm just answering your question. Yes.
thing I did 2 reflections and I translated.
Okay. Questions? All right. So I'll be after school today to get anybody has questions about the quiz, and then this homework's due on Thursday. Have a good day, guys. You guys will sign on tomorrow and start the homework. It's all out of the packet.
Sir, I do have a quick question.
Yep.
How would you do a reflection in that function notation? I know it's a lowercase r. But
Yep. Lowercase r, then you put down below what line you reflected over.
Okay, so it's just y-axis. It's not like x equals 0.
That you could do that. That's just another name for the y-axis. That's acceptable too.
All right, thank you.
Yep, you're welcome. Have a good day, guys.